in this video, I'm going to go over the questions on the review sheet that you guys wanted me to go over. Starting with number 4. The reason why you probably want me to go over this one is because my answer key is wrong, which is going to happen a lot because I'm not perfect. So if you see something that doesn't make sense to you and you think you're right, or you thought you were right, you're probably right. I'm probably wrong. So don't doubt yourself before you check with me. Because what I did was wrong. I factored this thing. You can't factor it, so you can't use the x-intercept method. You need to use one of the other two methods, completing the square, or that x is equal to negative b over 2a. I like using completing the square. I think it's easier, so I'm going to use that. So I'm going to take this equation that's in standard form, and I'm going to change it to vertex form by completing the square, since vertex form is the easiest one for me to graph. First thing I'm going to do is I'm going to focus in on the x squared and 2x. I'm focusing in on my x squared and x terms when I'm completing the square. I want to separate it from the constant that's there. So I'm going to separate it by putting it in parentheses. So I have x squared plus 2x in parentheses, and then the constant is going to be on the outside. The next thing I want to do is I want to make the thing inside the parentheses. I want to make that a perfect square trinomial so I can factor it to be some expression times itself, because that's what vertex form looks like. It's some expression times itself, or some expression squared. So I want to figure out what do I have to add to that to make it a perfect square trinomial. And the way I'm going to find that is I'm going to look at the number that's in front of x, and I'm going to cut that in half. So I have 2, and I'm cutting it in half, dividing by 2. That gives me p is equal to 1. P is the number that I want in my factored form, so I want to get this thing to be x plus 1 squared. Now I could either FOIL that out and see what I need to add to make it x plus 1 squared, or factorable to be x plus 1 squared, or I could remember that I have to take p and square it, and that is what's going to give me the number that I add inside. So I know p squared is equal to 1, because 1 squared is 1, and that's what I'll be adding to be able to factor into that. So inside of parentheses, I'm going to add 1. And then if I do that inside of parentheses, I need to make sure I'm taking away the same amount that I added to the right-hand side. I added 1 to the right-hand side, so I'm going to subtract 1 outside of the parentheses. The reason why I added 1 inside here was so I could factor that to be some expression times itself, and that is x plus 1 times itself, or x plus 1 squared. Plus, when I simplify what's on the outside, I get 7. This is my vertex form, which tells me that the vertex for this parabola, I know that the x value in my vertex is going to be whatever I'm subtracting inside the parentheses, which is negative 1. And then the number that is my y value in my vertex is the number I'm adding outside the parentheses, which is 7. So my vertex is at negative 1 comma 7 right here. That means my line of symmetry, since my parabola is symmetrical on both sides, my line of symmetry is the vertical line that goes through the vertex. And I just need one more point, just one more point, so a mini table to plot one more point on this parabola, and then I can use the line of symmetry to plot the other side, since it's symmetrical. A good value to pick in this case would be 0, because that's right next to the vertex, and 0 is always usually easy to plug in. So I'm going to plug that into this equation. I have to find what my y is. Y is equal to 0 plus 1 squared plus 7. So 1 squared plus 7 gives me 1 plus 7, which is 8. So when x is 0, y is 8. I'm going to plot that. It's right here. It's not going to fit on the graph, so you just have to estimate. I didn't estimate right. That doesn't look good, but whatever. And then on the other side, I know I can plot the point negative 2 comma 8. And then I connect these, and that's my parabola. The vertex of that equation I already found, it's negative 1 comma 7. The line of symmetry is x is equal to negative 1. The maximum or minimum value here, I have a minimum value, and that is going to be 7. The domain is negative infinity to positive infinity, and the range is, my lowest value, my minimum is 7, and I'm going to positive infinity. All right, next question was number 8. This is one of the word problems, the quadratic word problems. The Ecology Club is doing an Earth Day fundraiser with the bands from Battle of the Bands at BHS. The club president looked at the receipts from past fundraisers and found that the profit P could be modeled by the function P of T is equal to negative 15T squared plus 600T plus 50, and T represents the ticket price in dollars. So P of T is the profit, T is the ticket price. So I'm going to write on the side just to clarify what's my input, what's my output. T is going to be the price of a ticket, and that is my input. Oops. And then P of T, or just P, stands for profit, and that is my output. So T is like my X, and P is like my Y. Why isn't this letting me finish? All right. So I want to know what ticket price yields the maximum profit. So I'm looking for what's the input value that yields the max profit. If I see the word max or I see the word minimum, I know I'm looking for the vertex. I'm going to be looking for the vertex. So the easiest way to look for the vertex in these problems with equations that look like this. So most of these word problems, I'm going to use that formula. X is equal to negative b over 2a. But in this case, my x, I said, was t. My input value is t. So I'm going to use t is equal to negative b over 2a. And in this case, my a is equal to negative 15. Sorry. It's negative 15. And my b is equal to 600. And I'm plugging those values in. So I have negative 600 over 2 times negative 15. 600 over 2 times negative 15, which gives me 600 divided by 30, which is 20. So the ticket price, well, you don't have to write all this, forget that. The ticket price that yields the max profit is $20. Okay, and then what is the max profit? I'm going to use the ticket price that yields the max profit, plug that in, and see what I get for the max profit. So I have the equation, the profit, so P of T is equal to negative 15 times, in this case, I'm just going to put parentheses wherever I see T, and I'm going to replace it with 20. So I have negative 15 times 20 squared plus 60 times 20 plus 50. And that's going to give me 20 squared is 400. 400 times negative 15 gives me negative 6,000. This is going to be 12,000 plus 50, and then I get 6,050 is the max profit. So 6,050 is my max profit there. All right, next question. Number 11, I have a rancher fencing off a rectangular area bordered by a stream. He will use the stream for one side, so he only needs to fence off 3 of the sides. He has 100 meters of fencing material. And I want to know what's the maximum area that he can enclose. So when you see a question like this, when you see most word problems, it helps to draw a diagram. So that's what I'm going to do. I'm going to draw a diagram here on the side. I have a stream, and I'm going to make a rectangular fence next to the stream. And one side of what would be enclosed on the other part of the rectangle is actually the stream. So the stream is not going to be included in the fencing. I don't know what any of these sides are. I don't know what any of the sides are for this, these 3 sides of this rectangle. So I'm going to use variables to represent them because I don't know what they are. I'm going to let X represent the width of the rectangle. And if the left-hand side is X, then because by definition of what a rectangle is, the right-hand side is also going to be X. I'm going to use a different variable to represent the other side of the rectangle. So the length of the rectangle, I'm going to say it's z. I want all of these sides to be in terms of the same variable. So what I have so far is x plus z, that with the information I was given, can total 100 meters. So it can total 100. If I add them all together, it's going to equal 100. I can simplify this to be 2x plus z is equal to 100. And then what I want to do is I want to get z in terms of x. So I'm going to subtract 2x on both sides. That's going to give me z is equal to 100 minus 2x. And then instead of writing a z here, I'm going to replace it with 100 minus 2x. So now all of my sides are in terms of the same variable, and I can do this problem. I'm talking about the area. I want to find the maximum area. So first I need an equation for the area of this rectangle. I know area is equal to length times width. So I need to multiply the length times width here. I know the length is 100 minus 2x and the width is x. So I'm multiplying to find this output of the area. I'm going to multiply x times 100 minus 2x. I'm going to distribute that x to both things inside the parentheses. I'm going to use, instead of output, I'm going to write y, because that's what I normally use. That's a variable I normally use for output. And I'm going to get 100x minus 2x squared. Before I do anything else, I want to rewrite this so that it's with the highest power first, because that's how I find my a, b, and c. Or that's how it's easy to find my a, b, and c. You can still find your a, b, and c like this, but just so you don't make any mistakes, I have negative 2x squared plus 100x. And then I can very clearly see that my a is equal to negative 2 and the b is equal to 100. And that's going to help me with my next step, which is to find, I'm looking for the maximum. So I'm looking for the vertex. I can find the vertex by finding the x value or the input value of my vertex first, and then finding the output value from there. I'm going to use that formula. X is equal to negative b over 2a. So in this case, I have negative 100 over 2 times negative 2. So negative 100 over 2 times negative 2. And that gives me negative 100 over negative 4, which is 25. So I have x is 25 in the vertex, or x is 25 is the side length for the max area. So the two side lengths here are 25 and 25. You could figure out what this side length is by just plugging in 25 into that equation, or that expression. So I have 100 minus 2 times 25, which gives me that this side is going to be 50. So the max area is 50 times 25, which is 1,250. So that's 1,250, and I say feet squared. And you could have also taken this x and plugged it into this equation that we wrote to see what your y was. You could do whatever you want for that. Either way. For 12, I want to know what's the maximum product of two numbers whose sum is 30. So I know this is very similar to 11. I know I have two numbers here. I have number 1, I'm going to call it, and number 2. And I want variables to represent them. So number 1, I'm going to let be x, and number 2, I'm going to let be z. Just like in the last problem, I let one of the side lengths be x and the other side length be z. I want the product of these two. Oh, first what I want is one variable in terms of the other. So I'm going to use the information that's been given to me. I know the sum of the two numbers is 30. So I know that x plus z is equal to 30. Now I want to get one of these variables in terms of the other. I like to work with x, so I'm going to get z in terms of x, so I don't have to talk about z. I'm going to subtract x on both sides of this equation that I wrote based on the information that was given to me. I have z is equal to 30 minus x. I know z is equal to 30 minus x, so instead of writing z here, I'm going to write 30 minus x. Now I have two numbers, 30 minus x and x. Those are my two numbers. I want to know what's the maximum product. So the first thing I need to do is write an equation for the product. I know the product is equal to, I was gonna do x times z, but now I'm gonna do x times what I made z in terms of x. So 30 minus x, that's the product of the two numbers. I'm going to distribute that x. I'm gonna get 30x minus x squared. That's my equation for my output, or my area. I'm going to let y represent my output, and I'm going to rearrange this so it's negative x squared plus 30x. So I don't make any mistakes when I'm finding my a and my b, because I want to plug those into the formula. X is equal to negative b over 2a. So that's how I find my input value. I'm looking for the maximum, so I'm again looking for my vertex. And this formula, x is equal to negative b over 2a, is going to find me the x value in my vertex. For what my a is, I know my a is negative 1, since that's the number in front of x squared here. And then b is equal to 30, since that's the number in front of x. And then I plug those in. So I have negative 30 over 2 times negative 1. So negative 30 over 2 times negative 1. And that gives me negative 30 over negative 2, which is 15. So I know that x is equal to 15. So x is equal to 15. That's my number 1. And then my number 2 would be 30 minus 15, which is also 15. So the two numbers that yield a max product is 15 times 15. For number 14, I have how many times would the following quadratics cross the x-axis? So I want to write 0, 1, or 2, and then I want to talk about how do I know. Well, for zero solutions, my graph is going to look something like this. Not always exactly like this, but it's going to look like it's not going to touch the x-axis at all. So it could be there, it could be here, it could be here, it could be here, as long as it's not touching the x-axis. That's confusing, so I'm going to delete all of that except for one. Okay, when I have this, that means I have no real roots. So that's no real roots for 0. For 1, that means my graph is going to look like this. It's going to have one x-intercept, and that is going to be the vertex. So 1 root, and that's going to be the vertex. And then for 2, I know that the graph is going to look something like this. It's going to intersect the x-axis in 2 points. And so it's going to have 2 x-intercepts. Well, 2 roots. All right. And then I want to figure out how I would look at an equation and decide if it's one of these 3 situations. What I'm going to use is the quadratic formula, or I'm going to use just a piece of the quadratic formula. Because the first thing I want to decide is, am I going to have no real roots, or am I going to have real roots? So to find if I'm going to have real roots or not, I'm looking at what is the squared part of the quadratic formula, because I'm concerned if I have a real root or not, if there's a negative inside of that thing. So I'm going to do the square root of b squared minus 4ac, that's part of the quadratic formula, and I'm going to see, is this greater than 0? If it's greater than 0, that means I have either 1 or 2 solutions. It means I have 2 solutions. If I have the b squared minus 4ac, the square root of that is less than 0, that means I have no real roots. Or 0 x-intercepts. I should have been talking about this as x-intercepts. So let me erase this, two x-intercepts. And then if I have b squared minus 4ac is equal to 0, that means in my quadratic formula, what I'm adding or subtracting is going to be nothing. So normally I would have from that plus or minus two different answers, but if it's 0 that I'm adding or subtracting, I'm only going to have one answer. So this is when you have one x-intercept. Right? And that's how you tell. So sometimes you can tell by just looking at it. But if you look at this one here, you can tell because there's addition happening in between. If you were to set this y equal to 0, you could see very obviously x squared is equal to 4. That's going to give you two imaginary numbers. Sorry, negative 4. That's going to give you two imaginary numbers, so 0. For this one here, it's factored, but I don't even need to do the b squared minus 4ac because this is two factors. Tells me I have an x-intercept of 2, 0 and an x-intercept of negative 4, 0, so it's 2. This one here, I would have to use this 4, so I'm going to do the square root of b squared minus 4ac. That's the square root of 4 squared, which is 16, minus 4 times 2 times 11. And I can see that this number is going to be bigger than this number. So what's inside is going to be negative, which means 0 is the number of x-intercepts. And then for this one here, I could factor this thing. Instead of using this, I could factor this thing to be x plus 3 times x plus 3. Because I'm looking for two things that multiply to 9 and add to 6, which is 3 and 3. And these are the same, so this gives me 3, 0 and 3, 0 are my x-intercepts. That's my only x-intercept, so it's 1 solution. All right, for number 15, I'm going to sketch a parabola that has the given properties. So for the first one, I have a max of 15 and an axis of symmetry, which is the same thing as a line of symmetry. X is equal to negative 2. So I'm going to sketch this thing. I want a max of 5. And I want the line of symmetry to be negative 2. So I'm going to start with the line of symmetry being negative 2. So that's my line of symmetry. I want a max of 5. So I want 2, 3, 4, 5. I'm going to be here. Oops. I'm going to be right here. And I'll be going downwards because I want a max of that. So a possible equation, you can come up with whatever you want, but I know I have h is going to have to be negative 2, and k is going to have to be 5. And it doesn't matter what a is, so I'm just going to say whatever I want. So I'm going to say I want it to be, it matters that it's negative because I need a downwards parabola here. So I need negative 3 times x minus negative 2, which is plus 2 squared plus 5. So possible equation is, y is equal to negative 3 times x plus 2 squared plus 5. And then for b, no real roots, a vertex of 1/3. I know that this thing has to have a vertex at 1, 3, and then it should be going upwards from there. So I'm using y is equal to a times x minus h squared plus k. I know h is 1 and k is 3. And then I have y is equal to a times x minus 1 squared plus 3. It only matters that a is positive since I have an upwards parabola here. So I want y is equal to positive, let's say 1 times x minus 1 squared plus 3. So I'm doing y is equal to x minus 1 squared plus 3. And then, all right, for C, you should have gotten a sketch that looks like this. So 1, 0, 1, 2, 3, negative 3, 0. Those are my two x-intercepts. I have a y-intercept at negative 2. Oops. And then I'm going to connect these in a parabola shape. The only way to connect them is with an upwards parabola. what I'm going to do is I'm going to take my x-intercept and create my factors from there. That's going to go in my factored form. So I have y is equal to, I know the x-intercept of 1, 0 gives me a factor of x minus 1. And the factor of, and the x-intercept of negative 3, 0 gives me a factor of x plus 3. So I'm going to FOIL this thing, and I'm going to see that I get x squared plus 3x minus 1x is plus 2x minus 3. And this does not give me a y-intercept of negative 6. If I plug in 0 here, I'm going to get a y-intercept of negative 3. So I want to change that negative 3 to be negative 6. And the way that I do that is I multiply by I multiply by positive 2. So I'm going to multiply this by a positive 2. I don't really have a full equation yet, so I don't need to do that to the other side. I'm creating my equation, so what I'm going to do is just multiply all those terms by 2. I have 2x squared plus 4x minus 6, and that's going to give me a y-intercept of negative 6, and then I still have those x-intercepts are correct. So the only equation actually that you could write here is 2x squared plus 4x minus 6. Okay, then number 16, what's the minimum product of two numbers whose difference is 12? I know again I have two numbers, number 1 and number 2. Number 1 I'm going to let be x, number 2 again I'm going to let be z. I want to write one in terms of the other. So what I know is that the difference between the two is 12. So I know z minus x is 12. I want to get z in terms of x, so I'm going to add x on both sides. I'm going to get z is equal to 12 plus x, or x plus 12. I'm going to write this as x plus 12. So instead of writing z here, I'm going to write x plus 12. I have the two numbers then are x and x plus 12, and I want to find the product of them. So I'm going to write an equation for the product. So the product is, I'm going to take x times x plus 12. That's going to give me, when I distribute this x, it's going to give me x squared plus 12x, and that is my output, and that is, I'm going to let y represent it, and then I'm going to find the minimum product. So I'm looking for the minimum product, still looking for my vertex, so still going to use x is equal to negative b over 2a to find the minimum, the x value in my minimum, in my vertex. So I know a is equal to 1 here, b is equal to 12. I'm plugging this in, so I have negative 12 over 2 times 1. And I didn't need to write the 1, but I did. And then I get negative 12 over 2, which is negative 6. And that is my x value, so x is negative 6. So I know this is negative 6, that number, which means my second number is going to be positive 6. So the answer is negative 6 and positive 6. And then for 17, an angry bird is fired along the path. This is the equation given, negative 16t squared plus 256t. That's the equation for the height, where t is the seconds and is the amount of seconds that I've passed by, and height is in feet. So first thing I want to do is I want to say my t is my time, or seconds, and that is the input. And then I know that the height, or h is height, and that is the output. Okay, I want to know when will it achieve its max height, so I'm looking for, it says when, I'm looking for time, so I'm looking for t. When will it achieve the max height? Max tells me I'm looking for vertex. So I'm going to use this formula, x is equal to negative b over 2a, except x in this case, my input value is actually t, so I'm using t is equal to negative b over 2a. I know b in this case is going to be 256, and a is equal to negative 16. I'm doing negative 256 divided by 32, And that's going to give me 8, because it's a negative divided by a negative. I said it wrong. It's going to give me 8. So 8 seconds pass by for it to reach its max height. Next part is, what is the max height? Well, if it reaches its height in 8 seconds, I'm just going to plug in 8 seconds for t and see what I get for the height. Using the formula h that was given to me, h of t is negative 16t squared plus 256t. I'm plugging in everywhere I see a t, I'm plugging in 8. And then I'm just going to do this all on my calculator. Make sure you're doing 8 squared first. Powers or exponents and parentheses come before anything else. So I'm doing x squared, which is 64, times 16, negative 16, which is negative 1024, plus I have 256 times 8, which is 2048, and I'm going to end up with 1024 is the max height. Okay, that's the maximum height. And then I want to know, when will it hit the ground? Well, the information I know about when it hits the ground is that the height above the ground is 0, because it's on the ground. So it is not above the ground at all. So 0 is equal to, I'm going to use this equation here, except now I have my output that I can plug in, which is 0. I'm looking for my input. So I want to solve this thing just like I did all last unit. I have 2 terms, addition in between, so I'm going to use the square root method. I'm going to get the 16t squared to the other side. And that's going to give me 16t squared is equal to 256t. I'm going to divide both sides by, I messed up. You can't do that. Never mind. What am I talking about? You can't do the square root method because you don't have a constant here. So what I actually have to do is factor the right-hand side. I'm going to take out negative 16t. That's what I'm going to take out. And I'm going to have t squared minus 16. My bad. No, you're not. You're going to have t minus 16 times negative 16t. So I know that one of these two factors, negative 16t or t minus 16, it has to be equal to 0 for the product to be equal to 0. So negative 16t is equal to 0, or t minus 16 is equal to 0. For the first one here, I need to divide 16 on both sides, negative 16, and I get t is equal to 0, or on the right-hand side, I add 16 on both sides to get t is equal to 16. Now, t is equal to 0 does not make sense because, Angry Birds, I didn't write this in the question, but when you're playing Angry Birds, the Angry Bird doesn't start on the ground. Well, sometimes it does, right? Whatever, we're going to not count it because it's like having a negative time. It doesn't really make sense. So I'm getting rid of c is equal to 0, and I'm going to say, also because it didn't hit the ground, right? If it started at the ground, it started at the ground, but it didn't hit the ground. I'm talking about when it hit the ground, which has to be 16 seconds. And then I want to know, how long was it above 960 feet? So I'm going to have some parabola here. 960 feet is going to be, it's not the maximum because I know the maximum is 1,024. So it's somewhere before the maximum. And I need to find how much time has passed by between this point and this point. I know I'm going to have, when I solve this, I'm going to find 2 points because I was going up. I hit 960 feet going up, and then I'm going to hit it again going down. So I'm going to use this equation again that was given to me. And I also, again, have my output. I have the height, again, is 960. So I have 960 is equal to negative 16t squared plus 256t. And I'm going to get everything to one side. So I'm going to, I'm going to add 16t squared and subtract 256t. to both sides. And that's going to give me 16t squared minus 256t plus 960 is equal to 0. I can take a 16 out here. So I'm going to take 16 out. Oops. 16, I'm going to take that out. And I'm going to get 16 times t squared minus 16t plus 60 is equal to 0. And I need two numbers that multiply to 60 and add up to negative 16. And those two numbers are negative 10 and negative 6. So I'm going to have 16 times t minus 10 times t minus 6 is equal to 0. I know I'm solving for one of these two things has to be 0 for the product to be 0. It doesn't matter. 16 is not going to affect it. I could have just divided 16 on both sides instead of factoring it. So I know t minus 10 is equal to 0 or t minus 6 is equal to 0. I'm going to add 10 on both sides here, add 6 on both sides here, and I'm going to find that t is either equal to 10 or t is equal to 6. So that means that t was 6 here and 10 here. How many seconds have passed by in between those two times? And the amount of time in between is 4 seconds. So the answer is 4 seconds. And then 18, I've been given vertex form and I want to find standard form and factored form. So if I've been given vertex form, what I'm going to do is I'm just going to FOIL this thing and then simplify. I have x minus 1 times x minus 1. That's what that says. Minus 4. I'm going to do x minus 1 times x minus 1. That gives me x squared. Minus 1x minus 1x is minus 2x. Minus 1 times minus 1 is plus 1. And then I have a minus 4 outside. I'm going to just collect these and collect the constants. I get x squared minus 2x minus 3. And that is my standard form. So x squared minus 2x minus 3. Y is equal to that. And then factored form, I'm going to factor this thing. So I look for two numbers that multiply to negative 3 and add up to negative 2. And those numbers are negative 3 and positive 1. So I know because the coefficient of x squared is 1, I can go directly to factored form from here. I have x minus 3 times x plus 1, or y is equal to that. And then I'm going to graph this thing. So I have two x-intercepts. I have 3, 0 and negative 1, 0. So I'm going to plot those, 3, 0 and negative 1, 0. And then I also have the vertex from the vertex form. It's 1, negative 4. And I'm going to plot that, 1, negative 4. And then I connect these. I know my y-intercept. I can find very easily from the standard form. It's the constant there. It's what I plug in 0 for my x's. So I'm just going to be left with what the constant is, and that's 0, negative 3. The vertex I found was 1, negative 4. And the x-intercepts were 3, 0 and negative 1, 0. For number 19, I have standard form was given to me. I want to find vertex form, so I want to complete the square here. I have x squared plus 4x is going to go in parentheses because I'm going to separate it from the constant. I know I'm looking to complete the square inside here. At this point, we've completed the square so many times. I should know it's x squared plus 4x, and I'm adding 4. So I'm adding 4 inside of the parentheses, which means to keep the equation balanced, I need to subtract 4 on the outside. I get this factors inside of the parentheses to be x plus 2 squared. On the outside, I have minus 3. So vertex form is y is equal to x plus 2 squared minus 3. And then I'm going to, first of all, the y-intercept, I can just plug in 0 for x and in my standard form and very easily see that it's 0, 1. The vertex I can take from the vertex form here. I know what I'm subtracting inside of the parentheses is -2, and what I'm adding outside the parentheses is -3, and then the x-intercepts I can get by factoring this thing. So if it's factorable, and it's not, of course. So I need to use the quadratic formula to find it. So I'm going to plug these values into the quadratic formula. I know x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. And then I'm plugging in these numbers. So I have a is equal to 1, b is equal to 4, and c is equal to 1 as well. And then I just plug those in. So I have x is equal to negative, I'm not going to color code, -4 plus or minus the square root of b squared is 16. So 4 squared is 16 minus 4 times 1 times 1 is -4 all over 2 times 1, which is 1. And then I simplify what's inside of the square root, and I get the square root of 12 over 2. You have to simplify the square root of 12 to be, you can take out the square root of 4. So the square root of 4 times the square root of 3, that gives you 2 square roots of 3. So really here I have x is equal to -4 plus or minus 2 square roots of 3 over 2. And then you need to simplify the numbers on the outside. So you get x is equal to, you need to simplify the terms if they have something in common, and they all have a 2 in common. So really, if you divide all of these terms by 2, you get -2 plus or minus the square root of 3. If I divide all of these by 2. Or you can pull out a 2, however you want to do it. This is the solution. So it's -2 plus or minus the square root of 3. Those are the x-intercepts. So I'm going to plot the vertex -2, -3 right here, and the y-intercept, and then I'm going to say I don't want to do anything else. So, well, I'll have to plot the other side of this. So, right here, and there we go. And done. All right, and then number 20, I have, I'm missing, so I have missing points on this graph. I don't care about them. You don't have to fill them in. That's fine. I'm confident that you know how to fill in the coordinates of a given a point on a graph. What you need to do is find the equation for this. So I'm using the formula y is equal to a times x minus h squared plus k, because that's the vertex form, and that's the easiest one to plug things into. I know h in this case is -2 and k is -5, since those are my x and y in my vertex. H I'm going to change to be -2. K I'm going to change to be -5. I'm going to have y is equal to a is, I don't know yet. I'm going to have x minus -2, which is plus 2 squared, plus -5. I'm plugging in one of the points on this graph. So that was the point of you plugging things in. I'm going to use the point 4, 1. So I'm going to plug that in. I'm going to plug in x is 4, y is 1, because I have 3 variables there. I can't solve a 3-variable equation. I can only solve a 1-variable equation. And I need to figure out what a is, since I don't know what it is, but I do know an x and y that go together. So I'm getting rid of those 2 variables by plugging in that ordered pair. I have 1 is equal to a times 4 plus 2 squared. I don't know what the heck that is. That was supposed to be a plus sign. Minus 5. I'm going to simplify. 4 plus 2 squared is... Oh, did I mess up? No, I didn't. This is 36a minus 5 is equal to 1. I'm going to add 5 on both sides. And I'm going to get 36a is equal to 6. So I have a is equal to, 36a is equal to 6. I'm going to divide both sides by 36. I messed this up. This is wrong. Oh, because I messed up. I used the wrong point there. Okay. No, I didn't mess up this time. This is correct. I messed up on the answer key, so I'll fix that. And then I get a is equal to 1/6. And then I just plug that in. So my equation is y is equal to 1/6 times x minus, plus 2 squared minus 5. And then you can figure out the domain range and all of that stuff. The last question, I have x squared plus 2bx plus 11. And I want to know what b values would make it so that the minimum value of the parabola is 2. This is a completing the square problem. Because I want to turn this to vertex form so I could be able to see a minimum value of 2 in my equation. So I'm going to, first things first, I'm going to separate my x squared and x terms from everything else. So I have y is equal to, I'm going to put in parentheses, x squared plus 2bx, and then I have the 11 on the outside. I want a minimum value of 2. So I want a minimum value of 2, which means on the outside, what I want is 2. I want it to be 2. In order for me to get it to be 2 on the outside, I need to subtract something from this 11, this plus 11. I need to subtract 9. Most of the time I'm adding first in here and then subtracting on the outside whatever I added. But I'm doing this in reverse for this. So I'm subtracting 9 on the outside to get 2 on the outside, which means on the inside, I have to do the opposite of subtracting 9. I have to add 9. So what I need to figure out is what perfect square trinomial has a constant of 9. So x squared plus 2bx plus 9. I want to know what is 2b. What are the options for 2b? Well, when I have 9 as the constant in my perfect square trinomial, I know that that means that the square root of 9, because p squared is equal to 9, so I know that p is equal to 3. So I'm taking the square root of both sides here. So the number inside of my factored form is going to be 3, so I want x plus 3 squared. If I FOIL that, and you shouldn't have to at this point because we've done into this example so many times, I could find that, when you take the square root of 9, you have plus or minus 3. So I either have x plus 3 squared or x minus 3 squared. X plus 3 squared is going to give me x squared plus 6x plus 9, and x minus 3 squared is x squared minus 6x plus 9. So these are the two options. I'm looking for what's the coefficient of x there. So 2b could either be equal to 6 or 2b could be equal to negative 6. And then I divide both sides by 2 for both of these equations, and I get b is equal to 3 or b is equal to negative 3. And those are the values that would give this parabola a minimum value of 2.